Number 6, quadrilateral ABCD has those 4 vertices. So let's start by graphing these 4 vertices of 2, 4, 4, negative 1, negative 1, negative 3, and negative 3, 2. And we're starting here by determining if ABC is a parallelogram by showing that diagonals bisect each other. And when we're showing that diagonals bisect each other, the process that we're using is we're using the midpoint. So I'm going to start with diagonal AC. And remember, as I connect those points, C is out. I need to draw that a little bit better, negative 1, negative 3. So when we draw that, here's our triangle, and I drew that triangle that way, but it doesn't matter. You can draw it the other way, but it looks like what I did here is I went right, 1, 2, 3, and then I went up, 1, 2, 3, 4, 5, 6, 7. So when we're finding the midpoint, that's halfway between, so this is going to be right. Half of 3, which is 1.5. And this is going to be up half of 7, which is 3.5. So when we start over here at point C, I'm going to go right 1.5, and then I'm going to go up 1, 2, 3.5. So it's the green point there. I switched colors for a second just for a little contrast. But our midpoint turns out that it's going to be 0.5, 0.5. And if you want to write 1/2, that's fine. And what we want is we want that to match when we find our midpoint of DB. So our midpoint of DB, we're going to use the same process. We're going to draw a triangle here. So I'll go up and then over. Well, we went up. We're going to go up and then left is what it looked like when I drew it in. We went up 1, 2, 3. And when we went left, we went 1, 2, 3, 4, 5, 6, 7. Left 7. So we're going to go up 1.5. And we're going to go left 3.5. And as we go back and look at that, up 1.5. And then left 1, 2, 3.5, we do end up in the same place. So our midpoint is 0.5, 0.5, if you prefer, 1/2. As I go back and look at the directions, does it say anything about explain? And it does. So remember, take what's given in the problem and use it. For instance, I'm going to go back and I'm going to say that ABCD is a parallelogram because the diagonals bisect each other. I just used what's in the problem to make my statement. Our math supports it behind there, and here is our statement. ABCD is a parallelogram because the diagonals bisect each other. But eventually what we're trying to get to is we're trying to show that this is a square, and so we've done the parallelogram, and that means we're going to go on next here to figure out if this is a rectangle by showing that all 4 angles are right angles. And that means that we're going to be working with slope here. And I need to put my letters back in. but A and B, C and D, and we're going to be finding the slopes. We're going to figure out, well, what is the slope of DA, or AD if you prefer. We want to figure out the slope of AB. We also want to figure out what is the slope of BC. And we want to figure out what's the slope of DC, CD if you prefer. So when we go back and we look at the slope of DA, we're drawing our triangle. And what we did is we went up 2, and we went to the right 1, 2, 3, 4. 2/4. Which is 1/2 when we simplify. When we look at AB, what's going to happen is we went up 1, 2, 3, 1, 2, 3, 4. Let me go back here and look at DA again before I keep going on AB. We went up 2. We definitely did that. But I missed a point here. 1, 2, 3, 4, 5. There, I missed that 5. We went right 5. So we can't simplify that. And now, on AB, we went up the 1, 2, 3, 4, 5, like I had previously said. And then we went left 1, 2. The thing is to notice about those two is that they are opposite reciprocals. The fraction is flipped and the sign is changed. We come down here for BC. Well, we went down 2 and to the left. 1, 2, 3, 4, 5. Down 2, left 5. Remember, negative divided by negative is a positive. So now we have 2/5. And when we look at CD, we think we're going to get the opposite reciprocal of that. We went down 1, 2, 3, 4, 5. Down 5. And we went right 2. And that's what we see. It says, determine if ABCD is a rectangle by showing that all 4 angles are right angles. And I wrote a lot on this one. What I wrote is that DA and AB, AB and BC, BC and CD, CD and DA have slopes that are opposite reciprocals, which means that ABCD is a rectangle because all 4 angles are right angles. Pause the video if you want to write that down. I think you could shorten it a little bit just by saying that ABCD is a rectangle because all 4 angles are right angles. We have the math behind here to show that. Part C. We want to determine if ABCD is a rhombus. So, as I put the letters back in again on this one. Here's our A, our B, C, and D. We want to, again, diagonals are perpendicular. So we want to look at diagonal AC. So here's A, here's C. And I'm going to just look at that one right now before I jumble up the picture anymore. But we're looking at the slope. And 1, 2, 3, 4, 5, 6, 7. And then left 3. So we went down 7. We went left 3. And again, negative divided by negative, which is a positive. There's our diagonal for that one. If we look at DB, well, here's D, here's B. We want to look at the slope of that one. Well, we went down 1, 2, 3, and we went to the right. 1, 2, 3, 4, 5, 6, 7. And as we take a look at this, it's kind of the same reasoning as the last one here. I didn't write quite so much. So if we look at my explanation here, I can scoot it up a little bit. Diagonals AC and DB are perpendicular because their slopes are opposite reciprocals. So A, B, C, D is a rhombus. Again, pause the video if you want to write that down. But lastly here, what we're trying to come up with is ABCD a square? Well, because ABCD is a parallelogram, a rectangle, and a rhombus, the entire figure is a square.